School of Management Studies IGNOU presents an audiobook on the course MMPC 004 Accounting for Managers for MBA program. Block 3 Application of Cost Accounting. Unit 9 Cost Volume Profit Analysis.
The objective of this unit is to acquaint you with the nature of cost-volume-profit analysis, illustrate the factors which affect cost-volume-profit relationships, examine the role of break-even analysis by elaborating the cost-volume-profit framework, and discuss the applications of cost-volume-profit relationships in specific decisions. Introduction. Managers have to take frequent decisions which involve considerations of selling prices, variable cost, and fixed costs. Many of these decisions are a part of their planning responsibilities and have to be based on predictions about cost and revenues. Almost every question that is posed has a cost-profit aspect. You may react to what Holmgren states about cost-volume-profit relationships. And I quote, "Cost-volume-profit analysis is a subject inherently appealing to most students of management because it gives a sweeping overview of the planning process and because it provides a concrete example of the importance of understanding cost behavior, the response of cost to a wide variety of influences." Unquote. Probably you belong to the category of management students identified by Holmgren. If you have a propensity to know about the planning process and the cost behavior, you are sure to get at once interested in the study of cost-volume-profit relationship. What is CVP analysis? The cost-volume-profit or CVP analysis is an attempt to measure the effect of changes in volume, cost, price, and products mix on profits. You will appreciate that while these variables are interrelated, each one of them in turn is affected by a number of internal and external factors. For instance, costs vary due to choice of plant, scale of operations, technology, the efficiency of workforce and management efficiency, etc. Also, the cost of inputs bought externally is affected by market forces. While many wide-ranging factors influenced cost and profits, the largest single variable affecting them in the short run is the volume of output. Hence, the CVP relationship acquires a vital significance for the manager facing a wide spectrum of short-run decisions like what are the most profitable and what are the least profitable products? How does a reduction in selling prices affect profits? How does volume or product mix affect product cost and profits? What will be the break-even point if volume and cost change? How will an increase in wages and or other operating expenses affect profit? What will be the effect of plant expansion on cost, profit, and volume of sales? Answer to all such questions will have to be formulated in a cost-benefit framework, and CVP analysis will offer the technique for doing it. You may in fact perceive CVP analysis as one of the decision models which managers employ to choose among alternative courses of action. You may now be getting ready to comprehend the CVP concept. You will observe that profits are a function of the interplay of cost, prices, and each one of them is relevant to profit planning. The variance between actual and budgeted profit arises due to one or more of certain factors, which are selling price, volume of sales, variable cost, and fixed costs. You will also appreciate that these four factors, which cause deviations in planned profits, differ from each other in terms of controllability by management. It is evident that selling prices largely depend upon external forces. Costs, of course, are more controllable, but they pose a problem of measurement. There is more so when a firm manufactures two or more products. Nevertheless, knowledge of fixed and variable cost is essential if costs are to be controlled. You may try an answer to the question, how will cost change in the future situation? Would you succeed? Probably not quite so at this stage. But the CVP decision model will, of course, have an answer within its assumptive framework. Interplay and impact of factors on profit. We have said that cost and volume do influence profit. You will observe more objectively the extent and nature of this impact with the help of an illustration. It is proposed to evaluate the effect of number 1, price changes on net profit, number 2, volume changes on net profit, number 3, price and volume changes on net profit, number 4, an increase or decrease in variable cost on net profit, number 5, an increase or decrease in fixed cost on net profit, and number 6, all four factors, that is price, volume, variable cost and fixed cost on net profit. You must keep in mind certain points which we have discussed so far so as to develop understanding for subsequent sections. Number 1. CVP analysis explores the fundamental relationships between cost, volume, profit variables. You will observe that changes in volume influence cost and profit, and while this process gets underway, a stage is reached when the cost is equated with revenue at a certain level of output or at a certain volume of sales. This is recognized as the break-even point. You must understand that the break-even point is a point that is incidental to CVP analysis. Therefore, attempts to define CVP analysis as break-even analysis should be considered only restrictive. It must be admitted that break-even analysis does become an integral part of CVP analysis, but the two are not coterminous. You will grasp the CVP fundamentals along certain routes, which are number 1. First, the profit-volume relationship will be analyzed and the basic framework of profit graph will be presented. Number 2, the assumptions underlying the construction and analysis of a profit graph will be postulated and the concept of planned range of activity will be discussed. Number 3. A crucial step in understanding CVP analysis would be the segregation of cost into fixed and variable components. Procedures for doing this will be briefly examined. Number 4, the concepts of marginal cost and contribution will be introduced, leading to break-even analysis and margin of safety. Number 5, after understanding the conventional break-even chart, such charts for various purposes will be demonstrated. And number 6, CVP analysis will be presented in the mathematical formulations. With this, you should be able to understand practical applications of CVP analysis for business decisions. You will be expected to do assignments on these aspects. Profit graph. A business firm usually pursues a profit objective. In a way, it plans for maximizing its profit. Both the operations plan and the firm's overall plan are couched in terms of this profit objective, and their primary variables are cost, volume, and profit forecast for the planning period or horizon. The critical variable is usually the volume of sales forecast around which cost and profit estimates are built. A question often faced in the planning stage itself is, what will happen to profit if the forecast level of sales change? Such a question will not always be irrelevant because conditions change so rapidly. A manager seeking an appropriate answer to this question would want to get some guidance. The profit graph, which shows the relationship between profit and volume, helps provide the questioning manager with a possible answer. Please note that marginal income is the difference between sales and variable expenses and represents the total contribution to fixed expenses and profit. This term may be understood in another way as well. If variable expenses are expressed as a percent of sales, we get the variable cost ratio. Then, total contribution or marginal income is equal to the 1 variable cost ratio. Another term for marginal income is the P by V ratio or the profit volume ratio. You must note that the profit volume ratio is not obtained by dividing sales volume by profit, but by deducting the variable cost ratio from unity 1. With the primary purpose of the profit graph and some of its vital variables having been clarified, you may now move on to a hypothetical profit graph to comprehend the relationships involved. We may explain the construction of the graph to you and will then specify the assumptions behind this graph. OX on the x-axis provides sales volume and OY on the y-axis plots profit above zero and loss below zero. OFC measures a fixed cost. The line FCP joins 2 points with FC the fixed cost and P the profit expected to be released as the profit volume plan. The area encompassed by XBE is the margin of safety, while the point BE is the break-even point. BEPX is the profit area and the line FCBEP is the total contribution or the PV line. If the sales volume does not materialize at point X as per the plan and drops to X, the profit zone will shrink to a new profit area BEX. Further declines in sales volume will be absorbed by the margin of safety, after which losses will begin showing up. Assumptions in profit graph. You have understood the profit graph and you have got your first exposure to it. Maybe few doubts have started bothering you. Your queries may take certain forms, like how will the total contribution line emerge as a straight line if variable cost per unit do not remain constant, or if the efficiency of operations improves within the planned range of activities, and so on? You are probably right in thinking so. We have already stated that the CVP is a decision model. As with most such models, some simplifying assumptions undoubtedly make the underlying analysis a bit unreal but easier to comprehend. You may consider certain assumptions in particular. They are: Number 1. Variable cost or a constant cost per unit of volume. This will mean that the variable cost rate is constant even if the total variable cost will increase in direct proportion to an increase in output volume or sales quantum. Number 2. Total fixed costs remain constant throughout this planned range of activity. Number 3. The efficiency of operations remains unchanged throughout the planned range of activity. Number 4. All costs, particularly the semi-variable and mixed costs, can be separated into fixed and variable elements. Number 5. Selling prices per unit of sale remain constant. Number 6. Sales mix for a multi-product firm remains constant. Number 7. Volume is the only relevant factor affecting cost. Number 8. Factor prices, for example, material prices, wage rates, etc., remain unchanged. Number 9. Cost and revenue are being compared on a single activity base. For example, sales value of output or units produced. Further stock levels will not vary significantly in the period covered by the plan. And number 10. Variations in opening and closing inventories are insignificant. The important implications are there is a relevant range of activity over which cost behavior is linear, all prices remain unchanged, and cost can be classified into fixed and variable cost. Cost segregation. Some broad guidelines may be suggested to divide cost into two dominant groups, viz. Fixed and variable. They are listed as number 1. Costs that remain invariant to the volume of activity would be considered fixed. No costs are fixed forever. The concept is relative to the planning horizon, usually a short-run one, and the relevant range of activity. Number 2. Costs that vary in direct proportion to the volume of activity will be classified as variable cost. And number 3. Costs that otherwise belong to a mixed category, that is, which neither belong neatly to category A nor to category B, would in fact be apportioned to one of the two categories, that is, fixed or variable. If a mixed cost varies in some, not direct, proportion to output or volume of activity, it will be classified as a variable cost. On the other hand, if a mixed cost is predominantly fixed, it would be classed as a fixed cost. Methods to segregate cost. In the previous unit, various methods of segregating semi-variable cost into fixed and variable elements were discussed. Here, we are repeating two statistical techniques which may be employed to separate fixed cost and variable cost. These techniques are number 1, least squares, and number 2, scatter diagram. Marginal cost and contribution. Once the fixed and variable costs are segregated, it becomes possible to calculate the total contribution as well as total contribution per unit. You will recall that total contribution equals the difference between sales and variable or marginal cost. Total contribution per unit is expressed in per unit terms by dividing both sales and variable cost by the total number of units and deducting per unit variable cost from per unit selling price. The total contribution may be directly divided by total number of units to obtain similar results. You should remember that total contribution is the contribution of sales revenue to fixed cost recovery and profit after meeting the total variable cost. You may also recapitulate that total contribution may also be expressed as a percentage, which is recognized as the profit volume ratio. This is the 1 minus variable cost ratio, and variable cost ratio is sales divided by total variable cost. You must now understand the basic thrust of the profit graph presented in an earlier section. So far, you must be wondering how the contribution line was plotted on that graph. Now probably it is easier to comprehend. The contribution line is in fact obtained by plotting contribution per unit figures against different levels of sales values. You may switch back to the profit graph and have a real understanding of the contribution line. This line originates from the loss zone and raises up to the break-even point BE on the sales volume line. You may interpret this part of the contribution line up to BE, that is, the break-even point, as indicative of the recovery of fixed cost only. It is only after this point that the contribution line combines itself with the x-axis and the right y-axis to form a triangle PXBE, which has been marked as the profit area. Break-even point. We had earlier stated that the break-even point is not all that is contained in the CVP analysis. It is only incidental to such an analysis. You have already understood that the break-even point is just one point on the whole journey of the contribution line as it transits from the fixed cost point F to the profit point P via the sales revenue line with the x-axis. The horizontal intercept of the contribution line at BE is the break-even point. At this point, total cost and total revenues are held in equilibrium and a no profit, no loss position emerges. Margin of safety. While revealing the estimated profit or loss at different levels of activity, the profit graph also suggests the magnitude by which the planned activity level can fall before a loss is experienced. This is known as the margin of safety and is obtained by deducting the break-even sales from the planned sales. A graphical understanding into cost volume profit structures. Two cases of companies A and B are presented. You may examine the sales and total cost lines and offer your comments. You should note the differences between these graphs and the profit graph presented earlier. A significant difference between company A and B is in terms of the location and slope of their respective total cost line. Company A has a high ratio of fixed cost to total cost because the vertical intercept of its total cost line is very high. In contrast, Company B's vertical intercept is quite low and it has a low ratio of fixed cost to total cost accordingly. Hence, this would result in number 1. Once the break-even point is reached for Company A, large profits are made quickly as volume rises. The profit growth for the company is slower after this break-even point. Number 2. Company B, however, has the larger margin of safety than Company A and can therefore sustain difficult business spells without immediately cutting down on its level of activity. Company A cannot hazard a similar course and may have to shut down much earlier. Break-even chart. You will appreciate that the break-even analysis is a transitional stage of CVP analysis. Many authors discuss the interchangeability of these two because the derivation of break-even analysis from CVP analysis is very subtle. The break-even chart also emerges from the profit graph, but the total cost replaces the contribution line. The new relationships, which must receive attention in the wake of this major change. Purpose of break-even charts. The figures presented in this subsection provide a glimpse of the uses to which break-even analysis can be put. The objective is to offer a visual comprehension of a few illustrative situations. This will hopefully make the mathematical section more comprehensible. Now let's understand some of the abbreviations used in the unit. FC stands for fixed cost, C equals to contribution, P means profit, S means sales, P by V ratio means profit volume ratio, BE point stands for break-even point, MS is margin of safety, and VC means total variable cost. There are two important equations which are number 1, fixed cost equals to contribution minus profit, that is C minus P, or alternatively it is profit volume ratio into sales minus profit. Next equation is C, that is contribution equals to fixed cost plus profit, or alternatively P by V ratio, that is profit volume ratio into sales. Now let's summarize the unit. Cost volume profit analysis provides a framework within which the impact of volume changes may be examined on profit in the short run. Cost behavior is added as a dimension and corresponding changes in profit, break-even point, and margin of safety are observed. Break-even analysis is an integral part of CVP analysis, even though the former is just incidental to the latter. CVP analysis is used as a tool of planning. A profit plan is essential to be based on it. Several managerial decisions are often premised on this vital tool of analysis. Examples of such decisions are distribution channels, outside contracting, sales promotion expenditures, and pricing strategies. The conventional break-even chart is based on many assumptions, the most relevant being the planned range of activity, the short run, and linearity of cost functions. Many valuable conclusions can be drawn from CVP and break-even analysis. For example, number 1. A firm with a high proportion of the fixed cost to total cost is accompanied by a high break-even point and carries a potential for substantial profits once the break-even point is reached. Number 2. A company with a low proportion of fixed cost to total cost, on the other hand, commands greater flexibility in terms of profitable operation. Number 3. An increase in sales prices lowers the break-even point and increases the margin of safety. And number 4, an increase in cost pushes up the break-even point and lowers the margin of profit.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program course code MMPC 004 Accounting for Managers. Course Coordinator Professor Kamal Bagrecha, School of Management Studies IGNOU. Voiceover by Harpreet Kaur. Edited by Savita. Program assisted by Tarannum Jahan and Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.